Hi there, welcome to Super Physics, the online physics tuition service. Today I'm going to walk through of the WJEC AS Physics Unit 1. This is the new specification, and it's Unit 1, the motion, energy and matter. I'm going to divide this exam paper into each clip for each question, so you can quickly find the right question you would like help with. It's really important to start off that we have your data sheet, which is very important to you. And you've got a calculator as well, so you can either check your answers and check you're doing the right calculation. So for question 1, let's have a look. So this question is about density, and we have a student wishing to determine the what material a metal ball bearing is made from, given the mass and volume of the ball bearing. And the question says, calculate the density of the ball bearing in grams per centimetre cubed, and show that its percentage uncertainty, that's in bold, is about 5%. Okay, so looking at your equation sheet, if we go to the second page of your equation sheet, first equation, density is mass over volume. Okay, so always check the equation. So the first thing we're going to do in the answer is write down the formula. So density equals mass over volume. We need to check the units. This is in grams per centimetre cubed. The mass is in grams, the volume is in centimetres cubed, so there's no need for any unit conversion here. So the mass of the ball bearing is 45.4 and the volume of the ball bearing is 5.6. And on your calculator, you do 45.4 divided by 5.6 gives you an answer of 8.1. 8.1 grams per centimetre cubed. Okay. We also now need to show that the percentage uncertainty is about 5%. Now, in order to work out the percentage uncertainty, we look at the individual percentage uncertainty for each quantity. So for the percentage uncertainty of mass, you're going to do the 0.5 grams divided by 45.4 times by 100. Okay, and that will give you the percentage uncertainty of mass. So let's do it this way: 0.5 divided by 45.4 times by 100 gives you 1.1%. Okay, repeat the same procedure with the volume. So percentage uncertainty of volume equals 0.2 over 5.6 times by 100. 0.2 divided by 5.6 times 100 gives you 3.6%. Now, because we are dividing the two quantities of mass and volume, all we do is simply add up the percentage uncertainties. Okay, so over here we can say percentage uncertainty of density equals 1.1 plus 3.6, which gives you 4.7%, which is approximately equal to 5%. Part 2 of the question. Determine the absolute uncertainty. Well, the absolute uncertainty is the plus or minus bit. Okay, so say for example we take the example of the volume. The measured value is 5.6 and the absolute uncertainty is the plus or minus parts. In this case for the volume, we're 0.2. So to find the absolute uncertainty of density, all we need to do is we need to find 5% of the measured value. Okay, so we're going to do 5% of 8.1. So 0.05, which is your 5%, times by 8.1 gives you, so 0.05 times by 8.1 gives you an answer of 0.4, and we go around at 0.41. This is grams per centimetre cubed. Okay, and that gives you 1 mark. Now we're given a table of different materials, different metals, and the densities of different metals. Part 1 of the question, to be part 1, it says write down as many possible materials from the ball bearing, which ball bearing could be made from, and explain why it is not possible to determine the exact material. Okay, so if we look at our absolute uncertainty, we need to look at the upper and lower margins for which our density of the ball bearing could be. Okay, so the upper margin is going to be 8.1 plus 0.41. Okay, and that gives you 8.51 grams per centimetre cubed. Or the lower margin of error is going to be 8.1 minus 0.41, which is going to be 7.7 grams per cubic centimetre. Okay, so we're looking for any material, any metal, which is between those two. So it could be tin, no; stainless steel, no; iron. Now iron is in between the two margins, so it could be iron. It could be brass, or it could be nichrome. Okay, so we have written down the possible materials. Explain why it's not possible to know exact material. Well, the reason is because our these three materials lie within the margins of uncertainty. So the reason we say is these three metals lie within the uncertainty of the ball bearing. Okay. Part 2. Identifying the correct material from which the ball bearing is made depends on reducing the uncertain density. Explain which of these two values, volume mass, contributes more. Well, let's look at our calculations. For the first part, we found that the percentage uncertainty of mass is 1.1%. Percentage uncertainty of volume was 3.6. The percentage uncertainty of volume is much greater than percentage uncertainty for mass. So the volume contributes more to the certainty of density. That's stated there. We need to explain it. So the second one comes from saying because it has a greater percentage uncertainty. Okay, and that'll give you the second mark. So that was question 1, guys. We're now going to move on to question 2.